Okay, welcome everyone. We're going to start with systems of linear equations. Okay, so where you're going to see in the SAT is on two sections. You can see in both the no calculator section and calculator section. Both are possible. And you have two different methods of solving systems of linear equations. You can either one, use substitution, or two, use elimination. Both can always work, but sometimes it's better to use one or the other, but both ways you'll be able to get the answer. Okay, so let's start right away. Substitution. So here's our problem, and here are our steps. Okay, first step is you want to get one variable alone in substitution. So in our case, we already have that one variable is alone in one of the equations, just one of them. This equation's fine, we can ignore. But we have one already alone on one. What I mean by alone is that it's on alone beside next to the equal sign. Okay. Next step is, now that we know that y is equal to 2x plus 4, anytime we see y, we're going to replace it with 2x plus 4. Make sure to do it into the other equation. If you place it into this equation, it won't work. Okay, so replace it into this equation. And you'll see here what I did is I wrote 3x, and then instead of y, since we know y is equal to 2x plus 4, I wrote 2x plus 4. Always be careful if there's a minus sign here to put the minus and then parentheses, because if there was a minus here, although there's not, then it would apply to the 2x and the 4. Okay, continuing on, so we have 3x plus 2x plus 4 is equal to 9. Okay, moving on to the third step. Now we want to solve. So what I did here is I simplified. So I did 3x plus 2x, right, that's 5x, and then plus 4 is equal to 9. Then I subtracted 4 from both sides. Then you get 5x is equal to 5. Divided 5 from both sides and got x is equal to 1. Okay, so that's the third step right here. Moving on to the fourth step, we want to solve again. Now that we know x is equal to 1, we can plug it back into either equation. It doesn't matter which one. Plug it back in and get what y is equal to. So y is equal to 2. Make sure, see how right there I brought the 2 and then did parentheses replacing with what x is. So y is equal to 2 times 1 plus 4. So then we get y is equal to 6. So our solution is x is equal to 1 and y is equal to 6. So the overall solution to the linear system is 1 comma 6. That's typically how we write it because it's kind of like the x comma y. Okay, so let's move on to another example, slightly a little more difficult. And here's another example for substitution. So we have negative 6x plus 2y is equal to negative 18, and negative 5x minus 4y is equal to negative 32. Same steps again. Okay, so let's follow them through. We want to get one variable alone. So it doesn't matter which one, I just happened to choose the first one. So I decided to get y alone. So I just rewrote the first, this is the first equation. Then I added 6x to both sides, got this. 2y is equal to 6x minus 18. But y is still not alone because there's a 2 in front of the y. So I divided everything by 2. So that means dividing this by 2, which gets you to y. Dividing 6x by 2, which gives you 3x. Dividing negative 18, dividing that by 2, getting you negative 9. Make sure to do it to everything. Okay. Now we have y is equal to 3x minus 9. So that means anytime we see y, we're going to replace it with 3x minus 9. Okay, moving on to step number 2. We are going to replace the variable into the other equation. Again, do not put it in the first one that you just got that. Put it into the second one. Okay, so now we have negative 5x, right from here, and minus 4. Remember, again, the minus. So minus is going to apply to 3x and the negative 9 is equal to negative 32. Okay, step number 3, we're going to solve. So bringing this down, we have negative 5x. Now negative 4 times 3x is negative 12x. Negative 4 times negative 9 is plus 36. Be careful with that. People often make crazy mistakes with that. Okay, is equal to negative 32. Now, adding together negative 5x and negative 12x gives you negative 17x. Now you have plus 36 is equal to negative 32. Subtracting 36 from both sides gives you negative 17x is equal to negative 68. Dividing both sides by negative 17 gives you x is equal to 4. Okay, so now we have x is equal to 4. We can plug that back into the equation. Either one, doesn't matter. And get what y is equal to. So step number 4, solve again. Okay, now we have that x is equal to 4, so I plugged it into the first equation. Again, doesn't matter. Negative 6 times 4, be careful with the negative, plus 2y is equal to negative 18. So negative 24 plus 2y is equal to negative 18. That's just simplifying. Okay, then I added 24 to both sides, giving me 2y is equal to 6, divided both sides by 2, and got me y is equal to 3. So our solution is that x is equal to 4, y is equal to 3, and the solution to the linear system is 4, 3. So sometimes in the SAT they'll ask you what is x equal to, so you could just give that. Sometimes in the SAT they'll ask you what y is equal to, so you'll give them that. Sometimes they'll even ask you what x plus y is equal to, so then you have to do 4 plus 3. Be careful with that. Underline it if you have to remember it. Sometimes they'll say x, what is x? They'll give you this and say what is x minus y. So again, remember to do that last step, because sometimes you get the answer and you're so close, but then you miss that last step. So make sure to always do that. Listen to the instructions. Sometimes they'll just ask you what x is, and that's much more simpler. And we'll go into examples in another video. And if they just ask you what the solution is, then you give them 4, 3. Okay. So now moving on to the second method of solving systems of linear equations. We have y is equal to 2x plus 4 and 3x plus y is equal to 9. That's the first example we did for substitution. And the reason I'm doing the same problem again is because I want to show you that you can do it both ways. We have slightly different steps here. 3 and 4 is the same, that's solve and solve again. But we have 1 and 2 are different. Okay. So the first thing is you want to line them up, meaning you want to put them in this x plus y is equal to number format. So the second equation is good because it's in that format. You have the x plus y is equal to 9. The first equation, however, is not. We have y is equal to 2x plus 4. We want to get the x and the y on one side and the number on the other. So we're going to have to subtract negative 2x, so that's negative 2x plus y is equal to 4. Okay, now we want to cancel out the variables. Step number 2. Oh, sorry. First, okay. Here now, lining it up, just to show you. Now that I fixed the first equation, we're still on the first step, I'm sorry about that. We have negative 2x plus y is equal to 4. We have 3x plus y is equal to 9. That just lined up, basically. I just brought this equation here and brought it over here, and then copied this one over here, just to show you how nicely they will line up. Okay, now, step number 2, you're going to cancel out one variable. So, you can ignore this negative 1 for a second in these parentheses. Essentially, what I want to do is I want to find out a way to get one of these variables out. So, I learned that if you cancel out, if one of these y's were to be negative, right over here, if one of these y's were to be negative, then and we added them together, one of them would cancel out, leaving us just x's and just the numbers. And if that was a little confusing, you'll see exactly what I mean in a second. So if I multiply one of the equations by negative 1, in this case I chose to multiply the top equation by negative 1, I have to multiply everything by negative 1. That's why I did that parentheses to show you that I'm multiplying everything. So negative 2x times negative 1 gives you 2x, negative 1 times y gives you negative y, and 4 times negative 1 gives you negative 4. So you have 2x minus y is equal to negative 4. So now I'll show you what that exactly plays out to be. So now bringing us back to our original equation, if we bring our now modified first equation here, we have 2x minus y is equal to negative 4, and just bringing this down from over here, 3x plus y is equal to 9. Now, if we're to add them together, we now get that the negative y and y cancels out, leaving us with just 5x is equal to 5, right? Because I added these guys together. So now I'm adding everything together, and 2x plus 3x is equal to 5x, and negative 4 and 9 is 5. So that's step number 3, solving, basically adding them together. Once you have them canceled out, you add them together. Now if, like, for example, it was negative 2x plus 3x, then it would just be x. Just make sure you don't make that mistake. But in this case, it's just 2x and 3x. So now you have 5x is equal to 5. We're going to solve, and we get x is equal to 1. So step number 4, we're going to replace anytime we see x with 1 and get the answer for y. You can plug it into either equation, doesn't matter. So in this case, I chose to plug it into the top equation, and I did y is equal to 2 times 1 plus 4, and you get y is equal to 6. Therefore, our solution is x is equal to 1 and y is equal to 6. And the solution to the linear system is 1, 6. Okay, moving on to a little more complicated example, but again, the steps are still the same. Okay, so 1, line them up. But, as you can see, as I wrote here, they are already lined up. Everything is lined up. We have the x's and the y's lined up, and the numbers lined up. So that saves us a little bit of time. That's really nice. Okay, so now we want to cancel out a variable. So in this case, there's no just putting a negative. Like in last time, I'll show you last time here, we were able to just negate one of these and then cancel them out very easily. It was very nice. But in this case, that's not going to work. So what we have to do is we want to find the lowest common multiple for either y or x. So, like the number before y and x. So in this case, I chose to I figured that the lowest common multiple of 2y and negative 4y is 4y. Well, really 2y and 4y, but the common multiple would be 4y. So now I need to get one of those to be, I need to get negative 6x plus 2y is equal to negative 18 to have a 4y in it. So in order to do that, I'm going to multiply both sides to multiply this entire equation by 2. So that's what I did. I did 2 times negative 6x, which gets you negative 12x, 2y times 2, so 4y, and negative 18 times 2 is negative 36. So now, here we go. So lining up now our modified equation with the second equation, now we have negative 12x plus 4y is equal to negative 36. And now lining that up with our second equation, we have now if you were to add these guys together, 4y and negative 4y cancel out. Awesome. So now we're going to solve. So you're adding negative 12x plus negative 5x gives you negative 17x, and adding up negative 36 plus negative 32 gives you negative 68. Solving for that, dividing by negative 17 on both sides. And remember, when you divide by a negative divided by a negative gives you a positive. So x is equal to 4. Okay, now last step, plugging in. It's pretty easy. You just plug in, anytime you see x is equal to 4, you're going to plug it in to solve for y. So step number 4, I plugged it into the second equation. Doesn't matter which one you plug it into. And negative 5 times 4 minus 4y is equal to negative 32. Gives you to negative 20 minus 4y is equal to negative 32. Adding 20 to both sides gives you negative 4y is equal to negative 12. Dividing by negative 4 on both sides, y is equal to 3. So our solution is that x is equal to 4 and y is equal to 3. So the solution to the linear system is 4, 3. Alright, thank you everyone so much for watching. Don't forget to subscribe and like so I can continue to make videos. And feel free to leave any questions you might have in the comments below.